I was doing this transition, by the way, between physics and neuroscience, I discovered Bitcoin. In fact, I downloaded the wallet in 2010. It really changes your understanding of Bitcoin because what the power law is, it's really a framework. It's a framework to put in context Bitcoin, right? The first transaction ever between Bitcoin and USD, it actually falls on the power law almost perfectly. It's kind of crazy. Hey, you can take the log of the distance of a planet and the log of how much time it takes to go around the planet, and you will see this beautiful straight line. Right? It's a way of taking something that is non-linear and show a linear relationship between what? Between what we call scale. The coin went through a transformation of 8 order of magnitude. That means factors of 10. So one of the prediction is that Bitcoin is going to be $1 million.
Hey guys, welcome back to another show. Today I'm here with one of my favorite people, Giovanni. Andiamo. Come stai? How's it going?
Ciao. It is nice to have somebody from Italy, talking to. It's great. I love to meet other Italian Bitcoiners. It's amazing.
We exchange ideas, backgrounds. We did a beautiful intro that it was only for us. Sorry guys, but that
Yes.
was behind the curtains. We have a lot to talk about. I'm super excited. Finally, we are recording together. But before we dive into it, do you mind to give us an intro and tell us a little bit about yourself?
Okay, so my background is mostly academic. I have been, since I was a little kid, interested in science. I love to understand the universe, in particular, the stars, etc. I knew what I wanted to do from early on, and so I went to this path of being a physicist. I left Italy quite early. I came to United States. And I finished my PhD here in the United States. And then I became a professor, teaching in a small college, trying to balance my research and my teaching duties. In 2008, something because of the economical crisis and so on, they actually decided to reduce the physics department to actually keep it just few people that were doing mostly teaching for other departments because we were now in general there are not many physics students, but by the way in United States if you want to study physics you get scholarships, you don't have to pay anything at the graduate level, but because there are so few people. But in a small college like the one where I was teaching, we had like maybe one or two people a year, so we thought it was not worthwhile. So there are many people that need to study physics, but not necessarily they need to major in it, right? So they basically told me that I needed to find another job. But this was the year when I was supposed to get tenured, and that was the best in my department for all the time that I have been in this small college. So I was supposed to get it, but then there was this major change, and I didn't. So I had to reinvent myself. So I didn't want to try again, going through all the several years of trying to get a tenure track position. So I decided I'm going to do something different. So I went to the field of neuroscience. Also because my dad died of ALS, so I wanted to find a way of using my math and science skills to something a little bit more practical, even if I still love physics and astronomy and so on. Actually, it was an opportunity for me to scale up because I ended up in Northwestern, but it's like, famous university. And the reason I tell you this because actually it's relevant for my understanding of Bitcoin because it allowed me to apply physics to a different field and see how I feel. My initial bet was, well, I think that, having a physics point of view, having these more mathematical tools, being a programmer, because as a physicist, need to learn how to code, how to do data analysis of complex data. It will allow me to have an advantage relatively to people that maybe have a more biological background, if they don't know much math or whatever. And I was right because, I became an expert in a field that was new for me. In fact, I created a completely different field of neuroscience, inside of the neuroscience of sleep. I got a patent very quickly, while I was new to this field. So it was a very nice, bet that I did, calculated bet, and also it showed me how physics is a powerful tool to understand almost anything around us. And while I was doing this transition, by the way, between physics and neuroscience, I discovered Bitcoin. In fact, I downloaded the wallet in 2010. I didn't do much with it because at that time it was so complicated. Even with my computer background, coding background, I was not a computer scientist, and a lot of a language of how to use the wallet, all the things that you needed to do, were written in a way that it was mostly for people that knew that kind of stuff. So I put it in the back burner because I thought, okay, I can learn and I can understand it, but it will require a little bit of time. And then I forgot about it. And they still have a computer, even if it is a completely old computer that you cannot even use, almost as a reminder of stupid I was. Uh, and and I always say, you never, never, never put Bitcoin on the back burner. Never. When I try to orange pill people, I always tell them the story. Say, do it now. Don't buy Bitcoin while we are talking. Get a new wallet and even $10 buy Bitcoin. I send it to you. If so you get started. You never, never postpone. You never say, okay, I will do that tomorrow with Bitcoin. And I started to study Bitcoin actually scientifically even before I bought Bitcoin, because what happened later, um, I heard about Bitcoin again. Of course, I remember that I downloaded the wallet and I didn't do much with it, but it was in. I was part of this. I was very interested. Again, it happened more or less during this time. In this idea that we can use technology to enhance ourselves from a cognitive point of view. Maybe we can slow down aging, or maybe even stop aging altogether. It's an entire philosophical movement called transhumanism that is interesting to me. Uh, and this newsletter had an article about Bitcoin, because the angle was, uh, many of us in this movement want to change the world, right? We want to go to Mars, we want to create AI, we want to enhance ourselves or cure cancer or whatever. But you need a major economical resources to do these kind of things. And for one Elon Musk, you have thousands of other scientists or technical people that don't have resources. And this guy was saying, look at, you can buy Bitcoin. It's $9 at the time. The article at that time when the article was written was literally $9, and one day it will be $1 million. The article actually says that. Imagine saying this in 2012, right? It's completely crazy, because this when this article was. In fact, actually, I will send you a link to you, because it's really interesting to read these early on articles. But it explained it in a way that really made sense to me, all the technical detail, because this person was an engineer, he was a futurist, that he could see future trends, and then the other this vision of what Bitcoin is going to be, new monetary system. It was decentralized, all these things that I immediately understood. That when people tell me, oh, I did have a mistake of not acting immediately, right, when I downloaded the wallet, but I always understood Bitcoin. And I don't understand when people say, I didn't get Bitcoin at first, right? What do you mean? It's difficult for me to understand, because to me it was clear, was clear from the beginning. Maybe I was lucky to read this article, right? Spoke my language, that I completely understood. But at the end of the article, there was also a chart. Being 2012, the first exchanges opened in mid 2010. We didn't have a lot of data, right? So the chart didn't have a lot of information, and it was very difficult to make any prediction out of it, right? But the guy made two statements. One was that Bitcoin was not a bubble, because at that time a lot of people, it's something that we say less now, but we were using this word tulips, 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 right? That it was going to be like a bubble, and then it was going to zero, and it will never recover. And we had already a bubble, right, in 2010. I don't know if you remember, but I think we went to $20 or something like that, right? And then it collapsed to three. It sounds ridiculous now, but uh, it was shocking for many people that was this big change in price. But then Bitcoin recovered and it continued to go up. And so his argument was huge bubbles, a phenomena that are just a bubble and nothing else, right? It's not just like local changes in price, even dramatic change in price like this. Uh, Never recover. They go down, and this is it. And they say, look, actually it's recovering, so this means it's not the entire phenomena is not a bubble. And also, according to him, the price looked exponential. And exponential is something that resonated because a lot of these analyses about the future, like for example, is this engineer. His name is Ray Kurzweil. He wrote an entire book called The Singularity is Near, where he analyzes all these digital trends, not just Moore's law, but, the time it takes to discover the genome of a certain species, the cost associated with it, the advancement of AI, etc. He mentioned we will have AI around this time 20 years ago. This guy, Ray Kurzweil, did all this prediction based on using data to make long-term predictions. And many times when you're dealing with digital phenomena, you have an exponential growth. So I thought, oh, okay, so Bitcoin then is like one of these other phenomena. It's digital. It makes sense, but you will have an exponential growth, right? We had a too little data to understand that, also because of the bubble was creating a little bit of confusion, in terms of what to expect. But I started to download the data because I wanted to verify myself. I was a little bit confused because we didn't have a lot of information, but I had enough information to know that there was something very peculiar about Bitcoin behavior in price that seemed very organized. It went up in general. That was my conclusion. That I decided to go in, right? And in fact, at that time, I was moving from one job to another, so I could manage my uh, retirement, and I invested in Bitcoin. I was very much involved into Bitcoin at that point. Since then, I continue to go deeper and deeper in trying to understand Bitcoin, and I had some major breakthroughs that I can tell you how I actually discovered the power law.
I do have a call every month with Plan C and Sina. They are working on a model which was inspired by you, by the way. So
Yeah.
every time I encounter someone who is trying to measure somehow this beast of Bitcoin, your name comes up, right? Because you inspire basically everybody. And I think your idea and the power law basically gave other people opportunity to think about this model.
As a physicist, we are very familiar with these mathematical objects that we call power laws, right? And they are very different. They are related, but also very different from exponential processes. And in fact, for a physicist, what matters, right, is not just drawing some kind of a curve. Oh, this curve is explaining better than this other. Once you identify a power law in a phenomena, it's not just this straight line that you draw in a graph, in a log graph. That is what many people seem to think that the power law is about. No, that is like just the surface level of understanding of a power law. What is fundamental is that you don't have power laws by chance. You have them because there are some very precise mechanisms that give rise to them. And so understanding these mechanisms and why they have anything to do with Bitcoin is really the fundamental of this idea. And even if I am like 1/10 right, one like 10% of what I'm saying is right, it really changes your understanding of Bitcoin because what the power law is, it's really a framework. It's a framework to put in context Bitcoin, right? Why it's behaving the way it's behaving. what is happening, what are the interpretation, what are the consequences, right? If it is true that this power law is not by chance, that it cannot be, because you are asking me this question, right? Do we have enough data? In 2010, 12, when I started to analyze Bitcoin first, no, we didn't have enough data. Also because we missed the first year, we didn't have reliable data. Also because there were some scattered transactions. In fact, sometimes I include them backwards, right? So I don't use them, and then I say, using the model, could we go backwards and make sense of this early transaction? The first transaction ever between uh, Bitcoin and USD, it actually falls on the power law almost perfectly. It's kind of crazy. The first transaction was 5,000 Bitcoin for $1. Can you imagine?
Wow.
So, and that one actually falls on the model, on the trajectory of the model. Early on, the data was dominated by this huge bubble. There was a big chunk of the data, and it was so big that it was difficult to understand that there was a very precise pattern. Now, if you eliminate the bubble, you could have seen it. Actually, since the first early data, you eliminate the bubble, and there are several methods to do it in a coherent scientific way, not just arbitrary. Oh, this is a bubble. Let me take it off, and you will have seen the pattern. But it was not easy to think that that was the right approach to do. I discovered the power law because I was very familiar with this idea of power laws, because they come out all the time in physics. It's a physics tool. Like, in fact, it's such a internal joke that one time I found a shirt. I usually sometimes I show it in my presentation. I didn't create the shirt. You can find it online, and it says, "I went to a physics conference, and all what I got was a lousy power law," because a lot of the physics articles or presentation that people do in conferences somehow involve some power law, because they are so common in nature. They come up all the time. What I was not familiar with was that people in the physical with physical background started to study human phenomena, in particular the economies of cities, the economy in general, but in particular how city grows. And this is a perfect example of how power laws also impact human behavior. That is one of the things that many times when I describe this idea, I get pushback. I try to get inspired by Galileo in bringing these scientific ideas to something that for a long time was not studied scientifically, right? In this case, Bitcoin. I even actually in the process of creating an institute is going to call it Bitcoin Scientific Research Institute, where I want to emphasize how Bitcoin is such interesting phenomena that is not just an asset, a way of making money, a speculation. It's actually an entire phenomena that is worthwhile to be studied scientifically. So this is my particular angle, and this is why I have this Renaissance guide looking Bitcoin. Is this one where it puts Bitcoin in the context of these power laws in nature, but also human phenomena. So, like I say, I was very familiar with, for example, in fact, actually, I had experiences where I was trying to teach this kind of graph to students. Like in this particular case, I have this kind of strange experience teaching this to math, future math teachers, and many of them, unfortunately, go to this field, at least in the United States, because I think they cannot be good engineers, they cannot be good doctors, etc. And so somebody told them, "Hey, you can be a math teacher." This is why there is so much ignorance in people, knowledge of math, because they get these terrible teachers. And I was teaching a physics class for math teachers, and eventually went to my dean and said, "Please assign me anything, but I don't want to teach to these students anymore. These students that are going to be basically education students." But I was trying to explain exactly this graph where I was saying, "Hey, you can take the log of the distance of a planet and the log of how much time it takes to go around the planet, and you will see this beautiful straight line, right? And then I had a student, and she stood up and say, "Oh, this is too difficult for us to understand." And these were math majors, like at least education major, right? They want to be math teachers, and according to her, the log was too complicated of an idea uh, to understand. But so I was familiar with trying to actually educate people on these ideas of the relevance of these graphs, right? The reason why we take the log of a graph like this is because, first of all, what is a power law? Power law, it's a simple relationship, right? It's not that complicated if you have a little bit of math knowledge. It's basically y proportional to x, and then instead of being just a linear relationship, that is the simplest case. In fact, even that is a power law. It's a power law where the power of x is 1 in this case, if it is linear. In the more general case, the power, so x to the square, for example, right? So if you take the power, uh, if you have an exponent, that little number, it's a power, what is called a power. So in that case means if you have y equal x squared, that you double the x, whatever that is, right? Whatever quantity that is, and your y will go 4 times. If you triple your x, the y will go 9 times. So it's a non-linear relationship, right? And if you do this trick where you take the log, and it's easy to show mathematically, like if you have any math knowledge, you can try yourself and show to yourself as an exercise. I sometimes explain it in my videos. I have videos on my YouTube channel where I actually tutor about that. Eventually, I need to have a course or something organized. I didn't have a chance yet to do that, but you can show very easily if you have a relationship of that kind. And now, instead of two, make it n. N representing any numbers. It can be smaller than one, bigger than one. It can even be negative, right? So that is what a power law is when you have a non-linear relationship between y and x of this very, very simple kind, right? Where y is proportional to x to the n. If you take the log of both sides, the log of y and the log of whatever is on the left side, right side of the equation, you can show that now if your new y is log y and your new x is log x, like in this case, right, we are taking the log of the distance of the planet and the log of the time it takes for the planet to go around the sun, then you are going to get a straight line. So it's actually a simple way to identify power laws. Now, it's not the only tool. There are more sophisticated things that it can do to say, yeah, it's actually a power law, but it's the first visual approach, right? That if you have this almost perfect straight line, then you have a power law, and you can actually measure if you there are different mathematical tools where you can measure the slope of a line, and that slope now it's the exponent. You can again show using very simple algebra that the slope of this graph will give you the exponent. And humans like straight lines, so it's a way of taking something that is non-linear and show a linear relationship between what we call scale. So it's a very important concept, uh, and the scale is when you have a phenomena. If you have a phenomena that has changed many orders of magnitude, and with order of magnitude I mean the phenomena started, like for example with Bitcoin, right? We just mentioned the first transaction was $1 for 5,000 Bitcoin, right? So that meant that Bitcoin was a fraction of a dollar. So you start with something like a fraction of a dollar, all the way to $100,000, that is the price right now, right? So Bitcoin went through a transformation of 8 order of magnitude. That means factors of 10, right? $1, $10, $100, $1,000, right? All the way. 8 order of magnitude. That is 100 million. So Bitcoin went up by a factor of 100 million per. It is ridiculous, right? And there have never been a phenomenon like this in finance, right? Now there are, like for example, you can see here with the planet, right? So we have a graph. So first of all, you know that it's one of these graphs called the log graph, where you take the log of the distance and the log of the time, because notice how they emphasize these changes of 10, right? So 1, 10, 100. First of all, this AU means astronomical unit, so it is the distance between the sun and the earth. So I can measure the distance of the other planet as multiple of the distance of the earth from the sun. In this case, of course, earth will be one. Also, it takes 1 year for the earth to go around the sun. That it's a well-known thing. And then again, I can write all the other periods, right? The orbital periods as multiples of ones, right? And you can see, for example, by the time I go to Jupiter is, it takes about 12 years for the planet to go around the sun. It's almost 10 astronomical units. And notice, right, this phenomena covers kind of three orders of magnitude in the distance, because if you think Mercury as a fraction of a distance from the Earth and the Sun, and it takes about, like maybe kind of almost three order of magnitude in time, right? Bitcoin is eight, which is crazy. It's completely crazy. So it's even, imagine, it's almost like we are talking about how close Mercury is to the Sun, all the way to Pluto. In fact, many times more, because we are talking about eight orders of magnitude. Not, and why it's an important thing? Because in that case, you're not focusing on the little changes. You're focusing on how a phenomena changes over big enormous changes, right? So it's like many times I make the analogies like you have a forest. Instead of focusing on the trees, you're taking a drone, you're flying above the forest, and you're seeing the structure of the forest, how large the forest is, how it's growing, if there is any particular pattern in the forest, how the forest interacts with this environment, and so on. And this how why it's important, because when you focus on this scale, you are seeing things that you will not be able to see if you focus on the trees, right? If you focus on the little changes. And Bitcoin, it's really a scaling phenomena. This is what the message of a power law that many times people completely miss, right? Because they think, oh, it's just a line that is supposed to represent the price. No, I'm trying to tell you there is something special about Bitcoin, where it has special properties, where there is some order and some organization in how it scales up, how they, and this applies, we will see, or I can show you a graph that applies to almost all the other property of Bitcoin, how the addresses are growing, how the hash rate is growing. All the main fundamental properties of Bitcoin are scaling in a very precise fashion. Why I say that? Because if I focus on the scale, and the log is a way of bringing up the scale. Why? Because basically, if I can, if I have this quantity 1, 10, 100, and I write them as exponents, right? For example, 100 is 10 times 10, right? So I can write it in what is called the scientific notation as 10 to the 2, right? It's 10 to the square, 100. 1000 is 10 to the 3, 10 times 10 times 10, right? So if I write them in this way, and then uh, just to show how to think about these quantities in terms of these powers, right? So these are powers of 10, right? 10 times 10 and so on. So if I take the log, what the log does is a mathematical operation with basically, you can think like a box. I can put inside a number like 1,000, and it spits out three. It spits out the exponent, right? So it's a way of going from the number to the exponent. And the exponent emphasizes the scale. It's kind of linearizing these changes in such way that you're focusing on the scale. I know it seems a complicated idea, but for example, here in California, I live in California, we have earthquakes, right? Or you grew up in Italy, we have often earthquakes in Italy. We use this idea of a Richter scale, right? The Richter scale, it's a log kind of phenomena where if you go from earthquake 4 to an earthquake 5, four over five, 5 over 4, it's not a big change, right? But actually, what it means that we have something that is four, in that case, really what it means 10 to the four, so 10,000 to actually 100,000 when you go to five. That is, it's a little bit more complicated than that, but just to give you an idea, it's a change of 10 when you go from four to five, because what we are talking about, it's the scale, it's this scale concept that I'm trying to explain. The reason why we are making a big deal about these power laws is that if now you focus on the scale by using the log, you see order that you will not have seen it before. And the order is expressed by the straight line, because the straight line, it's a very simple relationship, right? It's a proportionality relationship. So remember when we say y equal x will be a very simple relationship between these two quantity. In the case of something complicated like the distance of a planet versus the time that it takes, that relationship is the distance equal proportional to the period 2 over 3. So it's not linear. But now, if I focus on the scale, it becomes linear. That means, the change in the scale. So if I double, triple, 10, 100 times, I make the distance of a period, let's say, bigger. So I look at planets that take longer and longer time to go around the sun. The scale in the distance will also change in a proportional fashion. And that means there is some kind of organization and some order that needs to be explained, right? A physicist will look at something like that and say, wow, means there is something underlying this phenomena because it's this behavior. Like even historically, for example, for Kepler's law, Kepler spent a lot of his adult life in trying to find some organization and some order in the solar system, because this was the beginning of the Renaissance. People started to think about using math and logic to understand the universe, and he was convinced that these motions of the planet had to have some kind of organization. And you tried all kind of things from the background of a time, platonic solid, all kind of crazy geometry and almost like kind of astrology, of a time, and nothing worked until he used real math. And the real math was a math of the logs. And when he plotted the log of the distance of the planet versus the log of the time that it takes the planet to go around the sun, he found this beautiful order. And immediately, being a good scientist, thought, okay, I found it. There is something deep there that cannot, needs to be understood and explained. It means there is some reason why the planets organize themselves in this way, right? And then it took 100 years, and Newton came about, and they say, I know how to explain this, because when we found it was just an empirical observation. He came up with this entire theory of physics, how objects move, if force equal mass time acceleration, and then using that formula, he tried to describe how something that moves in a circle behaves, and then if you introduce this idea of a force between the planets and the sun called gravity, and gravity work in a certain way, then you could derive this observational fact from the theory, and this kind of gave birth to science itself, right? So imagine all the beautiful things that we enjoy our days came actually from a power law, from understanding and going deeper inside the power law. So and people started to apply them to many other fields. Like for example, there is this beautiful power law found in biology that relates the size of an animal versus the energy consumed by the animal. I always suggest everybody to read this fantastic book. This is how I actually myself discovered that I knew about the power law, but I heard a talk by this British scientist online that was talking about human, using power law to understand human phenomena. And when I saw this lecture, it's called, in fact, is a lecture that is called. So this is the author, Jeffrey West. Everybody should read this book. This is the new Bitcoin standard. If you really want to understand Bitcoin, and even a small fraction of what I'm trying to describe to people is true, this book really opening your mind, because it doesn't explicitly talks about Bitcoin, but I'm going to write a book where I they use the same ideas but they apply to Bitcoin and they show the relevance of this idea of in Bitcoin. Is called the physics of Bitcoin. I'm working on this book, but this book contextualize this idea of scale uh, in everything. In fact, notice the subtitle: the universal laws. I emphasize laws. That is an important thing. The universal laws of growth, innovation, sustainability, the pace of life, organisms, cities, economies, and companies. So this was the component I didn't have. I knew about organism, but cities, economies, and companies, I was missing that piece. It's a new field in physics. In fact, there are branches of physics called econophysics uh, and social physics, where people are starting to use ideas and concepts from physics to understand human behavior and new human creations like cities. Uh, and I saw this lecture is called The Surprising Math of Cities and Corporations. And the guy, he's also a physicist, was describing how cities are organized. They look like living organisms. And, they have nervous systems with the communication system. They have a circulatory system with the roads, the streets. When I heard by this idea, I was there watching this 10 minutes TED talk. I immediately saw the relevance for Bitcoin. I thought, aha, Bitcoin is like this. And so I started to download all the data again. I was analyzing, and I found power laws everywhere in Bitcoin behavior. And I can ask you, does it look like Bitcoin is following a pattern when you look at the graph like that? Because I heard all kind of things, right? But some people say it's a graph that you cannot unsee. Does it look like Bitcoin is not random, but in general, right? That actually does follow a pattern?
Yeah, it does. Like the line you place there, I think it has a lot of sense. I mean, you could probably argue you could move it a little bit up, a little bit down, but it doesn't matter. It's still a
Yeah,
straight line going up, right? And
exactly.
the price seems to be gravitating towards the line more and more, which makes sense because an asset when it grows, technically the volatility should diminish. So it looks like he's in the beginning, the distance from the line when it popped out, it was much higher than the one in the end. So it looks like if anything is getting closer, the volatility is getting even closer to the line itself, right?
Yeah. So not just that, but in general, it doesn't matter, right? If I have huge big oscillations that go away from the power law. So first of all, this straight line is not calculated by chance, right? It's you using mathematical tools. It's called something that is called a regression line. Think about like an average, right? An average behavior that it's this line is trying to minimize the distance between the points, between all the points in the data. And there is a mathematical way of finding it, right? Now, if in my data was not really organized in such a way where most of the data is above or below in equal way relatively to this straight line, I will not get a good fit. And one of the measure of a fit is this quantity called R square, and it is a number between 0 and 1. you know One can go in the technical detail. Is it a good way of doing this? Is it a bad way? But roughly it tells us, given that closer and closer is to 1, better the fit is, right? For example, if we did it with the planet, we will get something like 0.99999. It will be incredible. With the animals will be a little bit less. In this case, it's 0.95. It means, in fact, zero point 0.5, 0.952 or whatever, right? And it's becoming better actually with time. I have one of my trading view indicators that is calculated this R square as new and new, more and more data comes in, and is actually going up. That number is going up. Now I think we are close to 97 or something like that. That means only a few percent, because one way of interpreting this R square is that 95% of the data is represented by that line. And and people that are not familiar with this will be confused. They say, "What do you mean?" Right? In fact, actually, very few points are on the line itself. If you notice, it crosses just a few points, right? There are not many points on top. Like if you look at the planets that are all on top, the animals, um, you know, many of them are very, very close to the line. Some are not, but with Bitcoin, almost none. But the mathematical idea is that it doesn't matter because in average, if an equal number of points are above and an equal number of points are below, they kind of cancel each other, right? From an average point of view. And so the result is that we get a straight line. They need to be explained because it's still interesting to see when we are deviating from the power law. This is why many times when people say, "Oh, is there anything that can break the power law?" Yeah, we had at least 4 attempts, right? Any of these bubbles is an attempt to deviate from the power law. But notice what happened: we reach a peak, and then we go back to the power law. Like you say, it's kind of an attractor, right? The price gravitates. That is another way of discussing that. Now, of course, we went deeper and deeper. Humans are predictable. The cities are human creations, and you can see so many metrics related to cities, even human behavior like crime, GDP, income, patents, how many patents are produced, uh, are power laws. You see, straight line in a log graph. Here explicitly they say take the log of a metric. You take you're trying to find a way of comparing there because we are different metric. You normalize them, whatever, it doesn't matter. So, but you take the log of this metric, whatever it is, one of these, and then you take the size of a city, the log of a population, and you see power laws, power laws, power laws, similar power laws. It's incredible. And this is another graph using China cities. In this case is the size of a city versus how much the square footage. This is kind of very interesting because it shows there is some kind of economy of scale. As you make the city bigger, the space utilized is more efficient. Um, but you could, again, there are people spending entire career trying to understand all these phenomena using these logs. So it's just the people that are not familiar because in Bitcoin you have all kind in the Bitcoin community you have all kind of background, people with different understanding, etc. But I would like to invite people to explore all these things because we are very, very relevant in understanding Bitcoin. It's a framework. This is why it's much bigger. People don't realize it's much bigger than just finding a model. The model thing is almost irrelevant. It's a new way of thinking about Bitcoin. You see, that is the importance of it. I don't show often this slide. This is to give you an example. This is in the field of neuroscience, where you find a lot of these power laws. Like I told you, I went to neuroscience at a certain point and started to apply some of these ideas and thinking about phenomena using this scaling behavior. Look how scattered this graph is, right? So this is a typical graph that you will find in biology where it looks like there is not even order there, right? And notice these are not even r square because if you take the square of a small number, it becomes even smaller. And so r's of 0.64, r of 0.54. These are, and you can publish a paper, right? This a published paper with data that roughly tell us there is some kind of scaling behavior. Again, these are all log graph between this whatever quantity we're trying to show. This is what is typical. This is why, when I went to biology, first of all, it was a shock that people could publish things with this. In physics, we will reject this paper. We'll say, there is nothing. Go and get more data, get more data because maybe with more data, you can reduce the noise, there is more clear of a pattern. But many times it's very difficult to get this biology data and they get published because it's enough to say, yeah, there is some kind of proportionality there. Compare this with this. It's crazy, right? Yeah, it's 0.95. It's really amazing to find this kind of correlation with the price of an asset. It means that Bitcoin is not a normal asset. There is some kind of mechanism that makes Bitcoin behave in a very precise fashion. I know it's a very difficult concept for many people to embrace. It seems crazy. This is why it's not, it should be like the accepted understanding of Bitcoin, but it's not, right? Like, it's not yet discussed by Sailor or Fidelity, etc. We should use these not because it's a model, because it's a framework in understanding Bitcoin, a powerful one. Because in the end, right, if there is a pattern, we can actually write down an equation. That is one of the things that physicists try to do all the time. We like to write an equation because it gives us an understanding, a simplification of a phenomena. I can write a simple equation to describe how the planets move around the sun. I can do the same thing with Bitcoin, right? In fact, in this graph, if we zoom in, I write an equation. That equation says that basically the price is proportional to time to a power. The power turns out to be 6, close to 6. And then, and time in this case is the age of a system, how old Bitcoin is, right? How many days are passed from the Genesis block. So one of the prediction is that Bitcoin is going to be $1 million in 8 years from now. And then it will take about 20 years to become 10 million. And my idea, there are several things to unpack from this. One is, I don't say it's certain because we are still dealing with an asset, so we're dealing with economy, finance, and so on, right? So there is some level of unpredictability that is not present in other things like animals, right? Or planets. But in general, if there is nothing major that can stop the growth of Bitcoin, that scaling behavior will continue. My way of thinking about this, to put it in a context, is to say, listen, Bitcoin went through 8 order of magnitude. We are talking about one more order of magnitude. Do you think that we will not be able to do that? I think so, right? There is nothing on the horizon that can stop. Yes, it's becoming more difficult because now we are talking going from market caps that were only tens of millions, hundreds of millions. Now we are talking about trillions. So, this is why we need, for example, institutions to come in and invest in Bitcoin and so on. But there is nothing impossible for Bitcoin. Bitcoin went through 8 order of magnitude. Now, can we do another order of magnitude? So can we go to 10 million? I think even that is possible. And this is where usually I stop because they say, well, when we arrive to 10 million, then we can consider. But at that time, we're talking about market caps that are equivalent to almost, half of the entire wealth in the world. 2 order of magnitude, I think, are more than possible for Bitcoin. And it gives us an idea of when we are going to do that. Because if you say, look, the scaling behavior will continue. And it's also give us a framework to understand, for example, the role of institutions. Because many times people push back and say, well, okay, but now things are different, right? Institutions are coming in. No, because of what the power law says is, well, by the time we are starting to play with elephants, right? Like in this graph of animals, right? We are going to see bigger and bigger entities, right? We're not dealing with mice anymore. We're dealing with elephants, but it's the same mechanism than before. It's just that now we're dealing with bigger and bigger entities, but they perfectly fit in this scaling behavior. They are not going to break the pattern. In fact, if anything, right now we are following the power law even more, since actually the ETFs are coming in. If anything, what the big institutions are going to do are probably going to dampen some of these oscillations. The volatility is going to reduce. There is more volume going on. It's actually going to follow more the power law than less. So you see how powerful this framework is, because now you're starting to understand. For example, a big question that everybody has in mind is when government will come in, right? Because right now it's more symbolic than anything else. When Trump signs uh, some executive orders, say, "Oh, we need to have a strategic reserve." We are not doing it yet, or at least we are not doing it with the volume which will be relevant. That will happen, but one can even use the power law and say when that is going to happen. When that is going to happen, when the right size is going to be equivalent, right, to nations. So when a market cap will be similar to the GDP of a nation, then this when the nations will come in. You see how it works? It's not it's not that we are predicting the coming of ETFs. We are saying in general that this is a scaling phenomenon. So it will make sense for the ETF to come in now rather than 5 years ago or 10 years ago. It will not have made sense from a scaling point of view. So it's a powerful way of thinking about Bitcoin. In fact, I think it's the main way that people should think about Bitcoin in answering all these important questions.
We should definitely do more session because there is so much to talk about, and I love your passion, and you have so much knowledge on the matter. So I'm really glad you came on the channel to explain to us. As always, of course, every single link is going to be in the description. So guys, if you're not following Giovanni, you have to follow the link and give him a follow. Maybe you can come back next time and we can dive into other parts of the
Yeah,
power law. That would be amazing.
for sure. Thank you.
Thank you. It's been great having you, Giovanni. And guys, thank you so much for watching, and we'll see you on the next one.